Okay, now we're going to get right into it. Hopefully this will be okay for you. We're going to follow the outline here and go with Roman numeral 2. We're going to learn about a statistic called a chi-square. So let's say, for the sake of example, you're on this class. Let's say we had 20 people in this class. Once again, you'll want to take some good detailed notes for this and form an outline. The idea of forming an outline is you're going to hopefully learn stuff in this class, and if 3 years from now you are asked to recite this information or share this information from others, could you actually write good enough notes in these drafts that you could look back at this a couple years later and actually have a good understanding of what we did and kind of retrace your steps. So let's just say, for the sake of example, that there are 20 people in this statistics class. Now, I know a lot of you probably have a fear of taking statistics. Let's say, for the sake of example, that 20 of you are taking this class and 18 of you are very scared about taking this class. Your attitude, you have a lot of anxiety. For the sake of argument, let's just say you have statistics-ophobia. That's, of course, a made-up word. So 18 people have a fear of statistics. 2 people are looking forward to it. They're going to make the rest of those people obviously look pretty bad as they go and do their work. So the question is, if you have 18 people who are scared and 2 who are not, are these results statistically significant? Many times when we do research in psychology, we try to figure out, are the results of a study due to chance, or are they due to some variable, and are they statistically significant? So we could ask that question about this particular study. 18 people are scared, 2 people are not. The question is, what is the statistic that you would want to use for this? The answer is what we call a chi-square. It's a chi-square. It's often called a chi-square goodness of fit. And the reason we can use a chi-square is because a chi-square is used to evaluate frequencies. In this case, we have frequencies. We have 18 people in one category and 2 in another. Now, what do you think about that? Do you think 18 out of 20 or 90% is statistically significant? Well, if you're betting that it is, you're probably right in this particular situation. A chi-square, though, is a statistic that we can use that will actually demonstrate if our result is statistically significant. So we're actually starting here very late in the book with chapter 17 with the chi-square goodness of fit. Looks like it starts on about, 594 of the textbook. You can certainly read through that or just try to understand the example here. I learned in version 2 of this book, so everything that I know kind of comes from this book, but hopefully what I share in my lectures simplifies things a bit for you. So 18 verses 2. On the outline, and in your book as well, there is a formula that we use. Let's see if we can find it in the book here. There it is, page 598 of the book. And in your notes, it's right there. It's called the chi-square goodness of fit formula. The formula for the chi-square and the symbol for chi-square is x2, x squared, although you don't have to square anything, is the summation. Oh my, we have symbols here. The summation of FO minus FE squared over FE. Now, I know those of you who had the statisticsophobia, I just say this, and you're like, well, what are FO, what are FE, and what the heck are you talking about? Hopefully you didn't say an FU. Oops. Little humor there. Har, har, har. So anyway, FO and FE. FO stands for the frequencies we observed. The frequencies we observed. So in our study, if we have 18 people who are scared and 2 who are not, we would probably have 2 FOs there. The frequency observed would be 18 for one group and 2 for another group. So you have 2 FOs, 18 and 2. The second thing is, what is the frequency expected due to chance? FE, the frequency expected due to chance. FE in this case, well, think about it here. How many total people do we have? 20. How many categories do we have? 2. So the frequency expected due to chance, if there is no difference, the frequency expected due to chance is going to be what? 10. 10 and 10. So FE in this case is 10 and 10. So we basically have all the numbers we actually need to do this computation. Why don't you actually see if you can put the numbers in and get the right answer out? Okay, the right answer from this should be the number of 12.8. See if you can get 12.8 on your own. And obviously my job is to make sure you can walk through this as well. So, how do you get 12.8? Well, you take the first FO, that could be either one of these numbers. Let's start with the 18. And it says, well, the first FO is 18. You would do 18 minus 10, because 10 is FE. 18 minus 10, quantity squared, over 10. So what is 18 minus 10 squared over 10? Well, 18 minus 10 is 8. 8 squared is 64. 64 divided by 10 is 6.4. And of course, you all know the famous Beatles song, what, When I'm 64. Of course, I was born in 64. That was during the Beatles, Beatlemania, as it turned out. And this isn't at all related to the class, but that's what makes this hopefully a little more interesting for you. My mom was actually in her third trimester when the Beatles wave hit the country. She probably got very stressed out. That could explain some weird behaviors as far as I'm concerned. But anyway, back to our story. So 18 minus 10 is 8. Squared is 64 divided by 10. So you've got a number there of 6.4. But then before you're done, it has that summation sign. You have to take the other number as well. What's the other number? 2. So we have 2, which is the other FO, minus the frequency expected, still 10, squared over 10. And you should hopefully get another 6.4 there. Notice values here are always positive because everything is squared. So your final chi-square value, 6.4 and 6.4, you add those up and you get a chi-obtained value of 12.8. Were you able to do that, I hope? I would expect you to be able to do some basic math in here. So you get a chi-square of 12.8. And the question is, well, is that a big enough value? Is that significant? In order to get the answer for that question, you would need to look on page 601 of your book. It actually has a chi table. And the way that we figure out if something is significant is we have to compare the score we get to a critical score. A critical score. So the number that we always use, and you won't need to understand this yet, this is kind of a cookbook thing, but if you look at table 17.2, we always use the value 0.05. So if you look in that column 0.05, then on the rows it has the degrees of freedom going from 1 to 9. Well, if you have 2 categories, the way we get degrees of freedom, if you have 2 categories, you always do 2 minus 1. So we have 1 degree of freedom, so the critical score in this case is 3.84. You see the value of 3.84 there? So the critical value is 3.84. Your obtained chi value is 12.8. If your obtained chi value is greater than the critical score, you are statistically significant. And so in this case, we could say we are statistically significant. And that's some good news. In the real world, what does that mean? Well, number one, it means we're statistically significant. It means a significant number of people are scared. And I don't know if this presentation has made you feel any less scared. I can only hope so. So the real world meaning, statistical significance, yes. Real world meaning, people in this class came in with an attitude they were significantly scared. 18 out of 20 is a significant amount of people. So we have statistical significance here. And then finally, the other thing we learn how to do is we learn how to write this out in APA style. And the way we do that is we write the chi symbol first, and then in parentheses, as you can see in the notes, the degrees of freedom. Do you remember what the degrees of freedom was? It was 1, comma, n equals, well, what was the sample size here? N equals 20, you write down. Close parentheses, and then you write the equal value for the chi obtained. Do you remember what the chi obtained was? 12.8. So the number there is 12.8, and then if something is statistically significant, at this point you simply write P is less than 0.05. I know a lot of this is cookbook for you now, but the idea here is that when we take a statistics class, we try to figure out if a result is statistically significant or if it's due to chance. In this case, 18 out of 20 is a lot. We did our chi-square, got a chi value of 12.8. That's much greater than 3.84. This result is statistically significant. We write it out in APA style, and the real-world conclusion is people are scared of statistics. Hopefully this makes sense to you, and you've gotten the right answer. The other thing I just wanted to share here, as far as real-world meaning here, is what would have actually happened if I had done this study and 10 people said they were scared and 10 did not? Could you figure out the math if 10 people said they were scared and 10 said they were not? Hopefully you can deduce that if 10 said they were scared, the FO would be 10, but so would the FE. If you get a chi value of 0, that means that there is no significant difference. That means your results are equal to chance. So, with this stated, hopefully you understand the key points that we're trying to articulate here. See if you can write out the steps. If you need to listen to this more than once, that's fine, but this is the statistical significance, or this is the how to do a chi-square situation. Thanks.